Hello students, so we are continuing with practice with me series. Okay, so we'll do today increasing and decreasing functions. Okay, the question is the interval on which the function is given f of x equal to 2x cube plus 9x square plus 12x minus 1 is decreasing. Okay, so you have to find the interval, okay, on which this function is decreasing. So first thing you have to do is you have to find the derivative. So derivative of this function with respect to x is, this is 6x square plus 18x plus 12. Okay, derivative of minus 1 is 0, so you'll get this. Now you can take 6 common, right? X square plus 3x plus 2. Okay, now find out the factors of this. So product is 2 and the sum is 3. Okay, so the factors are 2 ones are 2, right? 2 plus 1 is 3. So this can be written as x plus 2, x plus 1. Okay, so now you have to check for the interval on which this function is decreasing. Okay, so you have to find for the value of f dash of x where it is less than 0. Okay, less than or equal to 0. So if you take this f dash of x equal to 0, okay, you will get values of x equal to minus 2 and x equal to minus 1. Okay, now drawing the number line. So this is 0, minus 1, minus 2. So this is the interval, right? Now I'll take if you put minus 2 here, it will be 0. If you put minus 1 here, it will be 0, right? F dash of x equal to 0. Now you have to check for whether f dash of x is less than 0. So take a point which is greater than minus 2. So here if I take a point minus 1.5, okay, so minus 1.5, it belongs to the interval minus 2 and minus 1. If I put it here, so this will be, this is minus 1.5 plus 2, this is greater. Okay, the sign will be greater number sign, that is plus. Here it will be minus 1.5 plus 1, so minus 1.5 is greater here, so here the sign will be minus, right? You can write it like this. So I'll take x to be minus 1.5. So our f dash of x becomes, this sign becomes negative, positive, right? Minus 1.5 plus 2, and this sign becomes negative. So the final sign is negative. So f dash of x is less than 0 for the interval minus 2 and minus 1 when x belongs to this. If you take a number less than minus 2, that is minus 3, okay, and if I put it here, so minus 3 plus 2, it is negative, minus 3 plus 1, it is negative, so you'll get a positive number. So here all the numbers are positive. For this, if I take 0, x equal to 0, that is a number greater than minus 1. So if I put here 0, so it will be plus plus, okay, so this will be positive. So in between minus 2 and minus 1, it is negative. So f dash of x is less than or equal to 0 if x belongs to the interval minus 2 minus 1. So f is decreasing, okay, in interval this. Next question, find the interval in which the function is given is increasing. So you have to find the interval in which this function is increasing. Okay, first you have to find f dash of x. So derivative is 2x minus 4. Okay, then you have to put this equal to 0. So 2x minus 4 is equal to 0. So this is 4 by 2, which is 2. Okay, so x equal to 2 we are getting. So we are getting only one number. Okay, so if I draw it on a number line, so you will get two intervals, right? That is from 2 to infinity, okay, and from minus infinity to 2. That is this is, and this is 2 to infinity. And then you have to check whether it is increasing or decreasing. So if I take a number which is less than 2, suppose 1, okay, and if I put it on in f dash of x, so I'll take here x equal to 1, x equal to 1. Okay, so for this f dash of x is 1, so it is negative, right? If x is, this is x which is less than 2, okay, for x greater than 2, if I take 3 here, so it will be 6, right? 6 minus 4, 2, so it is positive. So for x greater than 2, f dash of x is increasing. Okay, so for the interval x belonging to 2 to infinity, this f dash of x is greater than 0. It is increasing. You can write it is increasing on the interval 2 to infinity. Okay. Okay, question 3. You have to find the interval in which the function is given f of x equal to sin x plus cos x, okay, is decreasing, and the condition is given, that is x is between 0 and 2 pi. Okay, so first you have to find f dash of x. So derivative of sine is cos, and derivative of cos is sine. Okay, now putting f dash of x equal to 0, so this is equal to 0, so you will get cos of x equal to sine of x, and we know the values of x for this type of thing, that is when cos becomes equal to sine, it is for 45 degree, right? Sine of 45 is 1 upon root 2, cos of 45 is 1 upon root 2, that is pi by 4. So for the values x equal to pi by 4. Now your interval is between 0 and 2 pi. So full 180 you have to take. No, 360, right? Like this. So for 45 you got the value. Okay. Now you have to look for another point x, okay, for which your sine and cos are equal. Okay, check for 135. In this quadrant you will get sine and cosec positive and all are negative, so you will get here sine positive and cos negative. So for 135 it's not possible. Okay, now for next one. Okay, so Next, you have to go in the third quadrant. In the third quadrant, tan is positive, right? And sine and cos have both have negative values, so both are equal. So this is possible. So here it is pi by 4, here it is 2 pi by 4, here it is 3 pi by 4, okay, 4 pi by 4, 5 pi by 4. So this value is 5 pi by 4. This is 6 pi by 4, 7 pi by 4. Here it is not possible because cos is positive and sine is negative here. Okay, both should be equal. So this is the value of x for which it is decreasing.